In this video, we're going to learn about Pythagorean theorem more or less. So we're determining what type of triangle it is. And so our step one is going to be super important. In our step one, we're checking to see if this is even a triangle. Okay, so we're going to check that the lengths can form a triangle, which just remember that's going to be the sum of two sides should be always greater than the third side. So the easiest way to check is just by picking the two smaller lengths and adding them together. And if it's something greater than the third side, then we have a triangle. In step two, once we've determined that it is a triangle, we are going to just let C be the longest side. And so for that, if C squared is going to be greater than A squared plus B squared, this is going to be an obtuse triangle. If your C squared is less than A squared plus B squared, it will be an acute triangle. And if A squared plus B squared is equal to your C squared, then the triangle is a right triangle. So let's look at some practice here. And I will start off by saying this video might be a little long just because there's quite a few practice problems. Obviously, you don't have to watch all of them, but I'm going to do my step one first. Okay, so I'm going to check to see is this even a triangle. So we've got 2 plus 5 is equal to 7. Therefore, that 7 is greater than 6, so it is a triangle. Okay, so now that I've done that, I'm going to now plug in and determine, based off my side lengths, is it acute, right, or obtuse? All right, so here I'm going to do my A squared plus my B squared, the two smaller sides. And I'm going to leave this blank here. I'm going to draw a line there because I don't quite know what the sign is. And then I'll have my C squared. Okay, so 2 squared is going to give me 4 plus 5 squared is 25. And then that 6 squared will give me 36. Okay, well, 4 plus 25 is going to give me 29. That is going to be less than my 36. So I'm going to fill these in. And therefore, since my C squared is going to be greater than A squared plus B squared, I know this will be an obtuse triangle. All right, now let's move on to number 2. All right, so my two smaller sides, we've got 5 and my 4, so 5 plus 4. And then we'll have, that's going to give me 9. And my 9 is greater than 8. And so this is going to be a triangle. So now let's determine what type. So we'll have that 4 squared plus 5 squared. And then we'll have my 8 squared. So that 4 squared is going to give me 16. 5 squared is 25. And then my 8 squared is 64. So 16 plus 25 is going to give me 51. And that is going to be less than that 64. And so therefore I'm going to have an obtuse triangle again. Okay, now moving into number 3. We'll have that 9 plus 40 is going to give you 49. 49 is greater than that 41. Therefore, we have a triangle. And so here we'll have that 9 squared plus 40 squared. And then we'll have my 41 squared over here. So 9 squared is going to give me that 81. 40 squared is going to give me 1,600. And then that 41 squared is going to give me 1,681. Okay, so adding these together, I'm going to get 1,681, which will be equal to that 41 squared that I got. So therefore, this is a right triangle. Okay. Number 4, we'll have that 2.5 plus 6 is going to be equal to 8.5. And then since my 8.5 is greater than 6.5, we have a triangle. So we'll have that 2.5 squared plus my 6 squared, and then my 6.5 squared on the other side. So 2.5 squared is going to give me 6.25 plus that 6 squared gives me 36. And then 6.5 squared is going to give me 42.25. And so when I add these together, I'm going to get 42.25 is going to be equal to that 42.25. So therefore, this is going to be a right triangle again. Okay, and number 5, we'll take that 6 plus 8 is going to give me 14. 14 is greater than 9, so this is a triangle. And then plugging in, we'll have that 6 squared plus 8 squared. And then my 9 squared on the other side. So 6 squared is going to give me 36. 8 squared is 64. And then we'll have 81 over here. Okay, so when I add the 36 and the 64 together, I'm going to get 100. And then since I have that 81 over here, we'll know that this will be greater than my 81. And so that's going to make this an acute triangle. Okay, moving into number 6. So in number 6, we're going to have that, I'm going to change this into decimals, but we'll get that 1.5 plus 3.5 is going to be equal to 5. And then we'll have that 5 is actually going to be less than my 6. So this is not a triangle. Okay, so when it's not a triangle like in this scenario here, then we are going to stop. We'll obviously say it's not a triangle, but we're going to stop. We're not going to then determine using the a squared and b squared and c squared what kind of type of triangle it is, since we don't have one. So we'll move into number 7. All right, so in this one here, we're going to have our 1 plus that root 2. And we're trying to just make sure that this is going to be greater than my 2. So this one's a little bit of a different scenario, but let's just kind of talk about what's happening here. So think about the fact that my square root of 2 is going to lie somewhere between 1 and 2, because we've got that the square root of 1 is just 1, and the square root of 4 is 2. So this is going to lie in between that somewhere. And so we know that this will have to be greater than 1, which means 1 plus something greater than 1 will automatically mean this is greater than that 2. So this is going to be a triangle. Okay, so just since we don't have our calculators, we're kind of justifying it that way. So then we'll move into plugging in. We'll have that 1 squared plus my root 2 squared. And then we'll have 2 squared over here. So we'll get that 1 plus that root 2 squared is going to just give me 2. And then 2 squared is 4. So we'll get 3 is going to be less than that 4. And therefore, this is an obtuse triangle. Okay, moving into number 8, we'll have that 12 plus 12 is going to give me 24. 24 is going to be greater than 14. So this is a triangle. So plugging in, we'll have that 12 squared plus 12 squared. And then on the other side, we'll get that 14 squared. So I'm going to take 144 plus 144. And then that 14 squared is going to give you 196. All right, so when we add these together, we're going to get 288 is going to be greater than that 196. And so that's going to make this an acute triangle. In number 9, we're going to have that 3 plus 3.5 is going to give me 6.5, which that 6.5 is going to be greater than my 4. So we have a triangle. So plugging in, we'll get that 3 squared plus my 3.5 squared. And then we'll have 4 squared over here. So 3 squared is going to give me 9, plus that 3.5 squared is going to give me 12.25. And then that 4 squared is going to give me 16. All right, so that 9 plus 12.25 is going to give me 21.25, which will be greater than that 16. And so this means that we are going to have an acute triangle here. All right, final one for these types of problems. We'll add my 6 plus my 10, which will give me 16. That 16 is going to be less than my 18. Therefore, I do not have a triangle. Okay, so we'll stop there and we'll move into our next problem. All right, so now let's look at our next set of problems, which they're going to use the instructions to decide if angle 1 is acute, obtuse, or right. And I think there's 9 of these problems we're going to do this for. So with this, I want to clarify To start it off, the determining of the acute, right, or obtuse triangle, it doesn't really kind of matter where that angle 1 is right now. We're still picking our two smaller sides to be our a squared and our b squared, and then our largest side to be our c squared. Once we've figured out what type of triangle it is, we can kind of look and see where the angle 1 is and determine what that kind of angle will be. So that's what we're going to do here. We're going to look at my triangle here and see that my two smaller sides are 5 and 6. So we're going to take 5 squared plus 6 squared. And then we'll get that 10 squared for my c. Okay, so 5 squared is going to give me 25 plus my 6 squared, which is 36. And then my 10 squared, which is 100. So when I add the 25 and the 36, I'm going to get 61, which we know will be less than my 100. Okay, so that means that this is going to be an obtuse triangle. But since we notice that that angle 1 is across from my largest side, we know that this angle here is the obtuse angle because of that reason. All right, so now let's look at number 12. So in number 12, right now we see that angle 1 is outside of our triangle. We're going to focus on using the triangle first. Okay, and so here we'll see that we'll have that square root of 6 squared plus my root 3 squared will be on my left side, and then on my right side I'm going to have that 3 squared as my c squared. Okay, and to clarify, I know that the 3 is the largest side because that root 6 is going to be between my square root of 4 and my square root of 9, which means it's between 2 and 3 somewhere. And so we know that that 3 is going to be larger. So now that we have it all laid out, let's go ahead and square. We'll have 6 squared is going to give me 6. Okay, plus that square root of 3 squared, which is just 3. And then my 3 squared is 9. So we're going to get 6 plus the 3 gives me 9, which we will get is equal to the 9. Okay. And so that's going to tell me here that this is going to be a right triangle. Okay, so I'm going to label that as such. Okay, so it's a right triangle, which since this is a straight line here, okay, and we know that that is 180 degrees, by default, we should be able to determine that that angle 1 on the other side will also be a right angle. All right, so now let's look at number 13. All right, so number 13, we see that angle 1 in this triangle here, okay? But I only know 2 sides of that triangle. I know the 7 and I know the 8. So what I need to do is I need to first determine what is this length here. And then I can use the a squared, b squared, and c squared to determine it, because that will give me all 3 sides. So since I do know this is a right triangle, I'm going to go ahead and use Pythagorean theorem. I'll have 3 squared plus my 4 squared equals to my c squared. And so I'll get 9 plus 16 is equal to my c squared. When I add that together, I'm going to get 25 is equal to c squared. And when I square root both sides, I'm going to get that my c is 5. So this length here should be 5. So now that I know that, I'm going to go ahead and plug in. We'll have my 5 squared plus 7 squared, my 2 smaller sides. And then we'll have 8 squared on the other side. So 5 squared will give me 25 plus 7 squared, which is 49. And my 8 squared will give me 64. So 25 plus that 49 is going to give me 74, which is going to be greater than my 64. And so that means that this is going to be an acute triangle. Well, because this is an acute triangle, that means all of the angles inside are going to be less than that 90 degrees, and therefore all of them will be acute angles as well. So that's how I'm getting my answer of acute. All right, moving into number 14. Okay, so number 14, we're going to bring back some of our similar triangles here to kind of help us solve it. And so what I notice here is that I do have our parallel lines. Okay, and so our parallel lines here in these triangles is going to create two similar triangles. And so I'm going to use that real quick to find this length here. Okay, so I'm going to use that side splitter theorem. So I'm going to have 4 over 2 is equal to that 6 over, and I'm going to just let this be x. And then I'll cross multiply. So I'll get that 4x is going to be equal to 12. Therefore, my x is equal to 3. All right, so now that I know that, I am going to look at the full side lengths, okay? So let me do this in another color. Here I'm dealing with that 4 plus 2, which will give me 6. And over here, I'm dealing with the 6 plus 3 to give me that 9. So with that being said, I'm going to plug in. We'll have that 6 squared plus 7 squared, and then our 9 squared. So 6 squared will give me that 36 plus 7 squared is 49. And then my my 9 squared is 81. When I add the 36 plus the 49, I'm going to get 85, which will be greater than my 81. And so since that means that they're all going to be acute, then my angle 1 should also then be acute. All right, in number 15. Okay, in number 15, we do have that angle 1 is going to be outside of our triangle. But let's go ahead and determine what the angles in the triangle will be, because we can use our linear pair here to help us determine what we know about that angle 1. Okay, so we're going to take my 8.5 squared plus the 9 squared. We'll have my c squared is 10 squared. So that 8.5 squared is going to give me 72.25 plus my 9 squared, which is 81. And then we'll have our 100 on the other side. So when you add the 72.25 and the 81, you're going to get 153.25, which will be greater than our 100. Okay, that means that this would be an acute triangle. Okay, and I'm going to write that acute triangle. Okay, that means that all of these angles here, here, and here, those are all going to be less than 90. Well, with that in mind, that angle 1 is a linear pair with an acute angle. So if we take our 180 and we subtract anything less than 90, we're going to be left with an angle measure greater than 90. And so that means that our angle 1 is going to be an obtuse angle. Okay, and then moving on to number 16, the last one for this front side. So the measure of angle 1 is going to be this angle here. Okay, and so in order for us to determine what that angle measure is, we need to know these two sides here. We need to know what is this length and what this length here is, because we already know that this one is going to be 7, adding that 4 and that 3. So in order to figure out those lengths, we are going to use Pythagorean theorem, because they do tell us here that we have those right angles. And so the two smaller triangles inside of it should be right triangles. So I'm going to solve for them. So we'll use that over here. We'll do this triangle on the left side. We'll get that 4 squared plus 2 root 3 squared will be equal to my c squared. So 4 squared will give me 16 plus that 2 root 3 squared. So 2 squared is 4. And then my root 3 squared is just going to be 3. Equals to that c squared. So we'll have 16 plus 12 equal to c squared. And so when you add those two together, you're going to get 28. And so I'm going to square root both sides. We'll get some factors are that 4 and that 7. So therefore my c is equal to 2 root 7. So that's going to be this side here is 2 root 7. Now we need to figure out the other side. So I'm going to do this in a different color. So we'll use that same 2 root 3. Oops. Squared. Plus, this time we'll use our other side length as 3 squared. And we'll have that equal to my c squared. Okay, so 2 root 3 squared, remember we said that that's going to be that 12. Plus the 3 squared gives me 9. And so 12 plus that 9 is going to give me 21. So when I square root both sides, I'm going to get that my c is equal to root 21. All right, so now that we have our 3 side lengths for that triangle, I'm going to just kind of draw a box here to separate. Now I'm going to determine what we know about that angle, okay? So I'm going to have my 2 smaller sides, so we'll have that square root of 21 squared plus that 2 root 7 squared. And then on the other side, we're going to have that 7 squared. All right, so that square root of 21 squared is going to give me 21 plus that 2 root 7 squared is going to give us, so 2 squared will give us 4, and that root 7 squared will give us 7. The other side will get that 49. So here we'll have 21 plus 28, so 4 times 7. And then we still have that 49 over here. So 21 plus 49, or sorry, 21 plus 28 gives you 49. Okay, so these are going to be equal. Therefore, this is a right triangle. Okay, and so if this is a right triangle here, remember that is also the angle that they did tell us was going to be the angle 1. And so that means that this is going to be a right angle as well. All right, so now let's go ahead and flip it over to the back side and see what they have for us there. So moving on to the back side, we've got, okay, yes, 3 more problems like that. So we are going to look here and we'll see that, yes, that angle 1 is outside of our triangle, but it is a vertical angle with this angle inside the triangle. So we can kind of use that to help us. So I'm going to say 6 squared plus my 12 squared. And then we'll have 13 squared. So 6 squared gives me 36 plus that 12 squared, 144. And then my 13 squared is 169. So 36 plus 144 is going to give me 180, which is going to be greater than my 169. So that means that this is going to be an acute triangle, which means that all of the angles are acute inside, and therefore the measure of angle 1 should also be an acute angle. Okay, moving into number 18. Okay, so number 18 here, we are going to look and see what sides of a triangle we do currently have. And what I do want to mention is I do have a small typo. Well, not really a typo, it's missing. This right here should be from D to C, a length of 24. Okay, so now that we have that, we've got our triangle that we are going to then determine what kind of triangle it is. So we'll have our 6 squared plus 24 squared, and then our 25 squared. So 6 squared gives me 36, plus that 24 squared gives me 576. And then we'll get that 25 squared will give me 625. Okay, so when I add the 36 plus the 576, I'm going to get 612, which is going to be less than my 625 that we got for our C. And so that means that this is an obtuse triangle. Well, since this angle here is going to be opposite of that 25, that longer side, that means that this angle is obtuse. Okay, so I'm just going to mark that this is an obtuse angle. Okay, and so what's very helpful in this problem here is going to be the fact that they do give us these parallel lines. Okay, and so remember, parallel lines here, we can then determine that maybe this angle here is congruent. Okay, so that means that this angle next to my angle 1 is going to be an obtuse angle as well, which, since these are forming a linear pair, a straight line, when we take that 180 and we subtract anything greater than that 90 from it, then we're going to be left with a number less than 90. And so that means that my answer is an acute angle. All right, so our last one for these types of problems. So here what we notice is that we have our triangle on this side, okay, given with 3 side lengths. So we're going to start off with that, and we can use that 8 squared plus 15 squared. And we'll have our 17 squared on the right side. So 8 squared gives me 64 plus that 15 squared, 225. And then my 17 squared is 289. So 64 plus 225 is going to give me 289, which will be equal to the 289 I got on the other side. Which means that this is going to be a right triangle, okay? And so that angle is a right angle. And since we know that these two angles here are congruent, and these two angles here are congruent, and we have this side here congruent, okay? We can use our congruent triangles to say that angle 1 is also going to be a right angle. And so my answer is right. All right, so now let's move into our last 2 problems. And so these will be a little bit longer, but we are determining whether it is possible to have a triangle from the given vertices. If a triangle does exist, then we want to determine if the triangle is obtuse, acute, or right. So I'm going to go ahead and just let you know now, we are going to have to use a calculator to actually prove this. And so when I'm coming up with my numbers and stuff, I'm using a calculator to get them for us to actually determine our final answer part of it. Okay, so let's first figure out what are the lengths that we're going to use for our 3 sides. So we've got our AC. So I'm going to plug into my distance formula to find the length. We're going to have 2 minus that -8, so plus 8 squared, plus my 3 minus 15 squared. Okay, and so going through and just simplifying, we're going to get that 2 plus 8 gives me 10 squared. Plus we'll have 3 minus 15, which will give me -12 squared. And when we square them, we're going to get 100 plus 144, which is going to be equal to the square root of 244. All right, so going through and just kind of getting practice with simplifying our radicals, okay, looking for some factors of that 244, which I can see here it's going to divide by 4. When I divide that by 4, I'm going to be left with 61. And so I'm going to get my final answer here is 2 root 61. Okay, now let's do this for the next side. So we'll have AB. Okay, and so plugging in, we'll have 2 minus that -5, so plus 5 squared, plus 3 minus -11, which will give me 3 plus 11 squared. Going through that, 2 plus 5 will give me 7 squared. Plus, and then we'll get that 3 plus 11 will give me 14 squared. And so 7 squared gives me 49, plus that 14 squared, 196. which when I add those together, I'm going to get 245. And so looking for some factors, we can do obviously 5, right? Because the last number ends in a number divisible by 5. And when I do that, I'm going to be left with 49. And so that's going to be a perfect square. And so we're going to get 7 from that. So then I can pull out a 7 with a leftover 5. All right, last side length for this problem here, we're going to use BC. And so BC, we're going to have negative 5 minus that negative 8, so plus 8 squared, plus, and then we'll have that negative 11 minus 15 squared. All right, so negative 5 plus 8 is going to give me 3 squared, plus, and then that negative 11 minus 15 is going to give you negative 26 squared. So when I square both of those, I'm going to be getting 9 plus 676. And when you add those two together, you get 685, which some factors of that are going to be 5 and 137, which doesn't really help me out any because that's going to be prime, and so I'm just going to be left with that square root of 685. All right, so now that I have found my 3 side lengths, okay, I'm going to notice here what I can determine without a calculator is going to be the fact that this side here and this side here are going to be my 2 smaller sides. Obviously, because if I look at the number underneath the radical, those are the 2 smaller ones. Okay. And so therefore, to determine if this is a triangle or not, okay, I'll just scroll over a little bit. We would have to take that 2 root 61 plus that 7 root 5, and we would need it to be greater than that square root of 685. Okay, so once again, this part is where I'm going to use a calculator real quick. So that 2 square root of 61 is going to give me about 15.62 plus, okay, and then we'll have that 7 square root of 5, which will give me 15.65. And then lastly, my square root of 685 is going to give me roughly about 26.17. All right, so when we add these 2 together, we are going to get, say, 31.27. And that will be greater than that 26.17 we got on the other side. And so this does make a triangle. So now that we know that this is a triangle, let's go ahead and plug in to figure out what type of triangle. Okay, so what I'm actually going to do is, this is going to help me out a little bit better. Is So I'm going to use that 244, that square root of that, squared, plus the square root of my 245 squared. And then we're going to use that 685 squared. Just because when I square that, I'm just going to get rid of the radicals. So I'm really just going to go ahead and have that 244 plus 245. And then over here, that 685. So when I add these together, we're going to get 489, which is going to be less than that 685. And so therefore, this is going to be an obtuse triangle. All right, so now we can move on to our last problem. And that's going to be question number 21. So we're going to do the same idea. Okay, so we are going to plug in to the distance formula to find the length of, we'll start with JK first. Okay, so I'll have that 1 minus -3, so plus 3 squared, plus my -4 minus -20, so plus 20 squared. And so when I add them, we're going to get that 4 squared plus, and then we'll get 16 squared over here. So 4 squared is going to give me 16 plus that 16 squared, which is going to give me 256. And this will be equal to the square root of that 272, which once again, I'm just going to practice getting used to simplifying radicals. So some factors of that 272 is going to give me 4 and 68. And then that 68 here can be broken down into 4 times 17. So that's going to give me 2 4s. So I'm going to pull out a pair with that 17 left over. So I'll get 4 root 17. Then moving into, let's find KL, the length of KL. So we'll have that square root of -3 minus 5 squared plus, and we'll have -20 minus 12 squared. Okay, so that -3 minus 5 will give me -8 squared plus, and then that -20 minus 12 will give me -32 squared. So -8 squared will give me 64. And then that -32 squared is going to give me 1,024. So when we add those two together, we are going to get 1,088, which some factors of that are going to be 8 and 136. And then we can factor that down into 8 and 17. So we'll have a pair of 8 to pull out with a leftover 17. So we will get 8 root 17. All right, and then for my final side, we are going to have JL. Okay, so we'll take 1 minus 5 squared plus that -4 minus 12 squared. Okay, so 1 minus 5 is going to leave me with a -4 squared. And then that negative 4 minus 12 will give me negative 16 squared. Which, if you look up above, okay, looking back up here, you'll see that we kind of had that. It was just positive. So we're just going to go ahead and we've got the same idea that we'll get that 16 plus that 256, which we said was going to be equal to that 272, which will reduce down to that 4 root 17. All right, so now that we have our 3 side lengths, okay, we're going to obviously take our 2 smaller ones. Okay, that's going to be these 2 here. And we're going to add them and see if they are going to be greater than our longest side length here. Because if they aren't, then we won't have a triangle at all to determine obtuse, acute, or right for. So here, if we take our 4 root 17 plus our 4 root 17 again, we will get 8 root 17. Okay, so because they have the same radicand, the same number underneath the radical, what we're doing is we're only adding the outside numbers. That's where we're getting that 8 root 17 from. And therefore, 8 root 17 is going to be equal to the 8 root 17 that we currently have for our longest side. And therefore, this is not going to be a triangle. Okay, because remember, they cannot be equal. It's the 2 sides should add up to be larger than the 3rd side. And since we don't have that in this scenario here, we know that this is not a triangle, and we stop it at that.